Hi, my name's Jeff Dean, and I'm Math Dad. I'm here to help you help your kids understand math. Today, I was working with my daughters on some of their math homework, and I noticed that they kept saying things like, "I'm done, I got it," when they were working out their problems, like, "Finished, done," and they just wanted to put their answers in, type them into the computer or write them down and just be done. And it got me worried because I was concerned that they were more worried about getting answers than understanding the concept that they were trying to learn. If all you do is get answers and you don't understand where those answers are coming from, chances are you're not going to be able to repeat what you did because you really don't understand what's going on. The way that I figured out that they weren't quite getting it is I started to ask them questions about why they were choosing to do the problems the way that they did it. Let me see if I can show you what I mean by looking at some problems here. Two people walk into a store and buy 3 cookies each. How many cookies were bought? You may look at that and go, "Oh, well, that's easy, it's 6. But the questions that I was asking them is, how do you know it's 6? Or how did you come up with 6? And the reason why that's important is because how they came up with 6 reveals what they understand about this problem. And it might reveal why they choose to do things the way they choose to do them. So, a couple ways that someone might approach this problem. 2 people walk into a store. There's person 1, there's person 2. Each one buys 3 cookies. 1, 2, 3, cookie, cookie, cookie. 1, 2, 3, cookie, cookie, cookie. So how many cookies were bought? Someone might say 6. How do you know? Because I counted them. 1, 2, 3 for the first person. 4, 5, 6 is the second person. So I just counted them all because I knew that there were 3 and 3. 1, 2, 3, 4, 5, 6. That person shows me that they knew once I had them all there, I could just count them. But someone else may say that, well, I have 2 people, and since each of them got 3 cookies, that is an example of 2 groups of 3, or 2 people getting 3 things. So I multiplied 2 times 3. Someone else might say, well, since the first person had 3 cookies, and the second person had 3 cookies, I went 3 plus 3. And that gave me 6. Each of those is a valid way of determining that they were 6. But what if someone said they did this? Well, the reason why I got 6 is because I know 2, 2, and 2. If I add 2 plus 2 plus 2, that gives me 6. 6 is the right answer, but does anything in this tell me that I have 2 of something, then 2 more of that, and then 2 more of that? Even though it got me the right answer, it reveals a misunderstanding of what's going on. Now, they may have chosen to do that because that's what 2 times 3 means, but that again tells me they know how to multiply or how to interpret multiplication, but don't necessarily have an understanding of the situation that they were being asked. Like the first 3 examples, the counter, someone who would just multiply, or someone who saw 3 plus 3. Those 3 people have an understanding of the situation and use their understanding to solve the problem. Let's take a look at an example that was similar to what my daughters were working on today. John needs 3.5 pounds of sand for his science project. The bag of sand he bought weighs 64 ounces. Does he have enough? So when we were working on this, the whole point was to work on conversions. And I had to do some leading to make sure they could navigate through this because it was new learning. But I started to see that they didn't necessarily understand where everything was coming from because they didn't know what all the numbers meant as we were doing the problem. We got to a point where we knew that since there's 16 ounces in a pound, they said, oh, that means we divide. I didn't ask how they knew they divided yet, but we got to that eventually. And then they just divided. They know how to divide. 16 goes into 64. They figured out that it was 4 times. They know that they go 4 times 16 to get 64. And they subtract, and they got 0. So I said, so what do you think? What's the answer? 4. No, 16. No, 0. Those are the types of things they were saying. They didn't necessarily go back to the problem. They didn't necessarily understand what these numbers meant. They were just, I have an answer to a division problem. That's my answer. But the question isn't how many pounds were in 64 ounces. The question was, does he have enough? He needs 3.5 pounds. And then I started to ask this question, what does the 16 mean? It's 16. Yes, but what does the 16 mean in the problem? It doesn't say 16 anywhere in there. No, it doesn't. But what does it mean? How did we come up with that? They had a difficult time answering that question. They should have been able to tell me because there are 16 ounces in 1 pound. That's what the 16 means. And I said, well, what's the 64? And they just said 64 ounces. Yes, but what does it mean? It's 64. It's right there. But what does it mean? They should have been able to say, because 64 ounces is what I have. And then when I asked them what the 4 meant, they're just like, that's the answer. That is the answer to this division problem, but what does it mean in the problem? What does the 4 represent? They really couldn't answer that question. And that's what led me to know that they don't understand the concept. They just know how to divide. But they were not going to be able to repeat this process because they couldn't make sense out of the problem. They didn't know what the 4 represented, or the 16, or the 64. They just could divide and get an answer once they had a division problem. Because they should have been able to tell me is 64 ounces is equal to 4 pounds. If they would have understood that, then I could have guided them back to, so does he have enough? If we go back to the problem, he needed 3.5 pounds. We have 4 pounds, so yes, he does have enough. They didn't have access to answering this question because they were so caught up and lost in the math because they didn't understand why they were doing what they were doing. And that's the point. If our kids are just doing work and getting answers, but they don't know why they're dividing or why they're multiplying or what the answer represents when it comes to the context of the problem, then they probably don't understand the concepts. They just know how to do the math. I could say with pretty good confidence that my daughters know how to add. They know how to subtract. But I could also say with confidence they don't always know when to add, and they don't always know when to subtract. Or they don't always know why they add, and they don't always know why they subtract. I could say the same thing about fractions. I know they know how to add fractions, but I'm not so sure they know why they add fractions or when they add fractions. If the problem is just given, they can do it right. You put it in a context and they don't understand. And to help get through that and see what it is they need to understand, you have to ask questions. You have to ask, what do the numbers represent? You have to ask them, can you draw a picture to show me what it is that you're thinking so that I as the teacher or I as the parent have a better understanding of how you're approaching this problem so I can guide you better and make sure you understand the whole thing. That is great work to be doing with our kids, whether at home or whether in the classroom. Make sure they understand the concept and not just get answers. Keep up the good work. My name's Jeff Dean, and I'm Math Dad. I just wanted to send a quick shout out to my friends at Whitebook, who provided me with this great board to do these examples for you. Thanks for watching, and I'll see you next time.